Welcome back, folks. This is Daniel for Rock the JVM. This video is the fourth and final part of the mini bank application using Akka, Cats, and Cassandra. And over the previous videos, which I recommend you check out, we wrote the important actors of the application and the HTTP server. And in this video, we're going to add some data validation using the Cats library to make our application a little bit more robust. We're also going to test everything, fix some bugs, and discuss our final lessons. So grab the code that you wrote over the past videos and let's continue. So here under HTTP, I'm going to create a new Scala object. I'm going to name this validation. And in this object called validation, I'm going to define some type classes that we are going to use for data validation, and I'm going to sketch a few. These may not necessarily be the most general for this application at the state that we are right now, but they may prove quite useful. So I'm going to imagine a few forms of validation. For instance, I might require a field to be present in a JSON payload. So here we have currency USD amount -55. For example, we can omit the currency USD and we are going to fetch the currency from the bank account itself, for instance. So the field must be present for the amount, but not necessarily for the currency if that is your choice. So I'm going to define a trait called, let's call this required, that will take a type argument A, and this extends predicate a Boolean to determine whether the field with the type A is present in the request. Also, we might want to not allow requests with negative balances if you, for instance, create an account. So if you create an account, you are not allowed to set the initial value negative. So I'm going to have, let's call this minimum value. And I'm going to define a trait called minimum of type A, and this extends a predicate, let's say a double arrow Boolean. So this is going to be for numerical values, so for numerical fields. Now, for this validation feature, I'm going to use the validated data type in Cats, which is able to aggregate a bunch of errors related to a particular piece of data and surface out all those errors. And I'm going to define a type. Let's call this validation result. And I'm going to give it a type argument A. And this is going to be a validated NEL. That is a non-empty list. And this validated NEL will take as argument the error type, which is in our case a string, or some case classes that wrap a string, and the type argument A for the desired value type. Now, instead of the string, I might be interested in creating a trait for that. I might create, let's call this a trait as validation failure, and let's assume that we have an error message as a string. And I'm going to use this validation failure instead of the string because I'm going to create some case classes for that. And let's say that for numerical values and string values, I'm going to create some examples of validation failures. So validation failures here. And I'm going to create, let's say, a case class. Let's call this empty field that takes a field name as a string, and this extends validation failure. Validation failure, assuming I can spend extends and validation failure. And the error message is going to be, let's say, I'm going to inject field name is empty. Let me create another case class. Let's use, for instance, a negative value. So I'm going to have negative value for field name as a string, and this extends validation failure, and the error message is going to be field name is negative. So we're going to aggregate all these validation failures for the appropriate fields, and I'm going to create another case class, let's say below minimum value for field name as a string and the minimum value as a double. and this also extends validation failure. And I'm going to override the error message saying that field name is below the minimum threshold, and I'm going to inject minimum here. So these are some of the examples of validation failures, and we're going to aggregate those depending on the presence of these minimal or required type class instances. And some type class instances, for instance, if I want to define a bunch of minimum instances for int and double, I'm going to create an implicit val. Let's call this minimum int, which is an implicit val. So an implicit val minimum int, which is minimum of type int. And I'm going to say, because this is a double arrow boolean, this is going to be underscore bigger than equal underscore. So that is the value that I'm interested in must be greater than the required value. And I'm also going to implement a minimal for double with the exact same form. And I'm also going to create an implicit val. Let's call this required string. And let's assume that the required string must not be empty. So this is going to be a required of type string. And I'm going to use underscore non-empty. So these are some of the predicates that I might be interested in while parsing the creation or update or other requests that I might want to issue. Now, if I want to use these type class instances, usage, I'm going to define some very simple API. For instance, I'm going to say required for a type A that tries to validate a field of type A or a value, let's call this value, of type A, as long as we have an implicit required as required of A. And this is Boolean, and this simply invokes the required predicate on that. So required on A, on the value. And I'm going to rename this to REQ so that we don't confuse the required value with the required method. And I'm also going to define something for the minimum thing. So minimum of type A, and I'm going to have a value of type A and a threshold as another A, actually a double, because that's how I compare that. And I'm going to require the implicit min as a minimum of A. This is going to be a Boolean. And I'm going to say min with value and threshold. So I'm going to simply invoke the API of the type class instance, whatever that might be. So once we have these in place, we can click some of these together. For instance, I might define a method, let's call this main API. And I'm going to define a method called, let's say, validate for minimum. So for any type for which there is a minimum type class instance in scope, I'm going to say validate minimum. And I'm going to pass a type argument A for which there is a minimum type class instance in scope. And I'm going to try a value of type A and a threshold, which is of type double. And let's say field name as a string, or maybe I should put the field name first. Doesn't matter that much. I'm going to return one of these validation results. So I'm going to have a validation result of type A. So because we have the requirement that there must be a minimum type class instance in scope, I can say if minimum the method here that requires the type class instance here. So if minimum between value and threshold is true, then I'm going to return this value as a desired value. So as a validation result. So I'm going to say value dot, and I'm going to use an extension method from the cats library. So I'm going to import cats implicits so that the compiler can give me all the extension methods that I want. I'm going to say valid NEL. Valid NEL is an extension method that is applicable for any data type, and this will wrap that in a validated NEL data structure here, which obviously conforms to the validation result type that I specified here in the signature. Cool. Otherwise, I'm going to try to say if the threshold is 0, then I'm going to return a negative value. So I'm going to say if threshold is equal to 0, then obviously the value is below 0. So I'm going to return a negative value here as an error. So I'm going to have negative value with field name. And I'm going to wrap that in an invalid NEL. So notice that this is an extension method from the cats library. Otherwise, I'm going to return a below minimum value error. So below minimum value with field name and the threshold. And I'm going to wrap that as an invalid NEL as well. So this method will take a value, a threshold, and a field name, and it will return a validation result, which we can then use to surface out errors to our user. So this API will try to make the whole process of validation a little bit more transparent to the user. That's the whole goal of this little attempt here. And I'm going to try to do the same thing for the required thing. So I'm going to have a validate required with a type argument a for which there must be a required type class instance in scope, value of type a, and a field name as a string. And this is going to be, again, a validation result of type a. Let me use the proper style here. And I'm going to say if required on that value, the required the method, which requires the implicit type class instance in scope, which is specified here in the type bound. So I'm going to say if required value, then I'm going to say field dot valid, not field, value. So value dot valid NEL. So this is a valid value, a desired value. Otherwise, I'm going to return this empty field case class instance. So empty field with the field name, and I'm going to wrap that as an invalid NEL. So these are our validation results. Now notice that the code that we wrote so far is pretty generic with a bunch of implementations for some types, but it's only applicable for individual fields, not for requests, that is HTTP requests, which was our goal all along. So our goal was to go to the bank router and validate the request itself. So I'm going to get back to this validation object, and in the so-called main API, I'm going to define a small trait. I'm going to call this validator. And I'm going to define a method called validate. And I'm going to have my value as type A. And this is going to be a validation result of type A. Now that I've defined my simple type class trait here, I'm going to define also a method that uses that. So I'm going to have validate, let's call this request, although this is pretty concrete, a name, but I'm going to leave it be. A, which takes a value of type A and an implicit instance, so an implicit validator as a validator of A. And this is going to be a validation result of type A, and obviously I'm going to invoke the validator, so I'm going to say validator.validate on A, on the value. All right, cool. So this is a general type class for requests, and I have the main API that we'll use to pass an HTTP request. Given a validator, we'll simply validate that and will contain a validation result, which will either contain that request or some errors that we can surface out to the user. That's the general gist, at least. So let's go back to the bank router, and here we will need to implement some type class instances for the requests that we are going to handle, which are bank account creation request and bank account update request. These are the JSON requests that we're going to handle in our HTTP server. So I'm going to define them in the companion object. So I'm going to have an object bank account creation request, and I'm going to define an implicit validator. So implicit validator as a validator of bank account creation request. Now, obviously, I'm going to import validator from the package. So I'm going to say import validator or validation everything. All right, so this is going to be our implicit val, and this is going to require the validation of every individual field, the user, currency, and balance. So this is a validator. Well, if I want to create a validator, I can create that as an anonymous class. So new validator of bank account creation request, where the override validate will take into account the potential value, the request. So request as a bank account creation request, and I'm going to validate each individual field. So let's call this, so we have user, currency, and balance. Let's assume that we want to require all of these. So we require the user and currency, and we also want the balance to not be negative. So I'm going to say user validation as validate required for the request.user. I'm going to run the same thing. So validate required for request.user, and the field name is user. Then we have the currency. So currency validation as validate. So validate, again, validate required on request.currency, and I'm going to call this currency. And we are going to validate the balance as well. So balance validation as validate required, not validate required, validate minimum for request.balance, and then we have the field name balance. All right, now I have a small error here because validate minimum requires a threshold as well. So I'm going to pass it as 0 here. All right, so we have 3 validations here that we can combine to maybe surface a giant error or a suite of errors that we can then surface out to the user. So I'm going to combine all of these. I'm going to say user validation, currency validation, and balance validation. And then I'm going to do something that's very interesting. I'm going to import cats.implicits.everything, and I'm going to run a small function that's called mapn. And mapn takes a function that will take all of these items, and if all of them are valid, then I'm going to create a bank account creation request again. So I'm going to say bank account creation request dot apply. So the way that this works is that if the user validation, currency validation, and balance validation are all valid results, so this validation result only contains the valid desired value A, so if all of these 3 contain the valid values, then I'm going to create a new bank account creation request out of those 3. If any one of those is invalid, then the final validation result of type bank account creation request will contain a non-empty list containing all the errors that might have occurred in either of these 3 expressions. So for instance, if the currency validation was successful, but the user and balance validation were not, then this whole mapn expression will contain a validation result where the error type is going to be a non-empty list containing the user validation error and the balance validation error, as we're going to see in the console. Now, this is quite involved, and it uses the Cats validated data structure to automatically aggregate those into one magical expression, which allows me to write this very, very succinctly here. I teach this in the Cats course, by the way, and we spent roughly an hour just on this sort of mechanism, so I'm skipping a lot of steps along the way, but I'm pretty sure you get the idea. Cool. So this is the validation for the bank account creation. We also need to do a very similar thing to the bank account update. So I'm going to run an object, bank account update request, and I'm going to have an implicit val validator as a validator of bank account update request. And this is going to be a new validator of type bank account update request, where the override validate takes a bank account update request, and it will have to validate these two items. So I'm going to return a validation result. So validation result of type bank account update request. So I'm going to run the user validation, the currency validation, and the amount validation. So I'm going to copy these two, and we have the request here. So request. We have currency and the amount. And let's say that the minimum amount that you can either withdraw or deposit is, let's say, 1 cent. So 0.01 of any currency. So nothing smaller than that. All right. And I'm going to then run another map n. So I'm going to have not balance validation. I'm going to call this amount validation. I'm going to wrap this tuple currency validation and the amount validation map n, and I'm going to create this bank account update request.apply. So we're following a very similar pattern here. Now I can also use the single abstract method pattern. So instead of creating an anonymous class, I can run a function, but I wanted to make this super explicit. Cool. So we have implicit type class instances for the requests that we want to handle. Right. Now, bad request if something wrong, and bad request if we don't have this valid. All right. Let's try to define a small method to validate a request. So I'm going to have, let's call this validate request. And I think I have the validate request name in the validation bit. We have validate request. Let's rename this. I'm going to call this validate entity or something. And I'm going to come back to my routes. So validate request for the type R from request, for which there is a validator in scope that takes a request as an R. And this validate request will need to take a further directive here that we can use if the request was valid. So I'm going to call this route if valid. And the data type of the route itself that we are going to wrap here is called route with a capital R that I'm going to have to import from Akka HTTP, Scala DSL. And finally, I'm going to return another route, which is the same kind of DSL that we defined earlier. So this is pretty much a piece of an HTTP server logic. So I'm going to use the validate entity method that we created earlier. So this one that requires the implicit validator type class instance. So validate entity on request. And we're going to run a pattern match because the validated data type in cats can be pattern matched. And we have two cases: valid with a value, which contains the actual same request. I'm going to use cats data validated. So valid on whatever, because I already have the request. Then I'm going to return the route if valid. So if the request was validated by the validator logic, then I'm going to return the route that I wanted in the first place. And in case I get an invalid with a bunch of failures, so failures, and then I'm going to return a complete directive with a bad request. So I'm going to have status codes dot bad request, and I'm going to return what? I return a failure response. So this is the data type that we defined earlier. So I'm going to have a failure response that will simply collapse all the failures into one. So I'm going to have failures.toList, and I'm going to return the error message. And then I'm going to make string with, let's say, a comma or something like that. So all the failures will be collapsed into one giant string that will give me all the reasons why that request was bad. Cool. So this is pretty generic. Now I'm going to use this at the top of this onSuccess thing, because after I've parsed the entity from JSON, I'm going to validate it. So I'm going to add the validation here. So validation. I'm going to say validate request on the request. And I'm going to wrap this whole thing. All right, so we have bad request if something wrong, and also here in the bank account updates. So I'm going to copy this one, the validate request. So validation, I'm going to tab this whole thing further, and I'm going to wrap it in the validate request directive. This is a custom directive that I've created. I hope this works. So let's restart the application. Hopefully we haven't killed anything or anyone or anyone's bank account in Cassandra. All right, cool. So no errors. And let me go ahead and try to create a bank account. So I'm going to have an HTTP post, and instead of saying user Anna, I'm going to say user, let's say Spider-Man, and I'm not going to pass anything else. I'm going to pass just the user, and the currency and amount I'm going to leave blank. Let's see what we have. So we have bad request. So the request content was malformed. Attempt to decode on failed cursor down field currency. Okay. This was a bad request from parsing in the first place. So this Akka HTTP server returned bad request in the first place. Let's say currency equals whatever and amount or balance equals minus 10. Hopefully this works. All right, so notice that in this case, the payload was properly parsed, which is good. And notice that we are now returning a bad request with our own logic. And the reason says currency is empty, balance is negative. So both errors were surfaced to the user. Cool. Now, this is the same kind of error we're also going to see if we do the put thing. So I'm going to run an HTTP put, and I'm going to use Daniel's bank account with DDA. I remember that one. So instead of currency, I'm going to leave blank, and amount, I'm going to say 0.0001. Let's see what we got. So now we have a bad request saying currency is empty, balance is below the minimum threshold of 0.01. All right, so we can now surface multiple errors to the user and help them understand what was wrong with the request. And one last test that I want to make is try to withdraw more money than I have in my bank account. So I'm going to say currency is USD, and the amount is -55, and balance is below the minimum threshold of 0.01. Well, we have a bug here because the amount here must be greater than 0.01 in absolute terms, which means I need to run a different kind of validation. So here under the validation type, I'm going to define another type class. I'm going to call this minimum abs, in minimum for absolute value. And I'm going to copy these two, and I'm going to run some type class instances for minimum abs. So I've defined some type class instances here, and the minimum int abs is going to be a math.abs. For the first argument needs to be bigger than the second argument, and same for the double thing. All right, I'm going to also have a method that does pretty much the same thing with minimum abs. So value threshold implicit min as a minimum abs. So I'm going to call this method one more time. So this is good. And I'm going to define another method, validate minimum abs, with a type argument a for which there's a minimum abs in scope with a value of type a threshold, which is a double, and the field name, which is a string, and this returns a validation result of the same type. And I'm going to run a pretty similar logic. So if minimum abs with the value and the threshold, then I'm going to return value.valid nil, non-empty list. Otherwise, I'm going to return below minimum value with the field name, and the threshold. And I'm going to wrap this in an invalid NEL. Okay, so now we have validate minimum abs. Now, I'm going to go back to my bank router and I'm going to add some validation here under the validator. So in the bank account creation request, I'm going to modify the balance validation to be above 0 and also be in absolute terms bigger than 0.01. So I'm going to combine that with, I'm going to use that, with combine with validate minimum abs with the same argument. So request balance the 0.01. This is the absolute terms. And then I'm going to have my same balance field here. And same for the bank account update request. So validate minimum request amount 0.01. This is validate minimum abs here. So just the minimum in absolute terms, I don't require this to be either positive or negative. Only that in absolute terms, this should be bigger than 0.01. And let's try rerunning this. Because we've just changed the logic of validation, so the Akka HTTP server should be intact. Let's try to modify Daniel's bank account with -55. All right, so saying bank account cannot be found. This is a different bug, which is great. Let me run an amount 0.001 just to make sure that the threshold was matched successfully. So we have balances below the minimum threshold 0.01. Now this is not balance, but this is the amount. Amount it's called. Let's try to rerun this because otherwise the error might be misleading. We have the server up and running. Let's try this again. All right, so amount is below the minimum threshold 0.01, and this is the same if I want to deposit or withdraw a smaller amount. So amount is below the minimum threshold 0.01. Okay, cool. Let's try to fix this one with a bank account cannot be found, and I think I know what's happening here because after we get a none here, we return a not found, and a none is also returned if you try to withdraw more money than you have in your bank account. So we need to fix that, and we need to return a different kind of data structure. So I'm going to go back to my persistent bank account, and in the bank account updated response, instead of an option, I'm going to return a try. So I'm going to return a try from Scala util, and now I have some compiler errors. And in case of none, I'm going to return a failure. So I'm going to return a failure with a new, with new runtime exception saying cannot withdraw more than available. And in the case of sum, I'm going to return a success. So success is the equivalent of sum in the try world. So now in the case of failure, we also have the reason why that operation failed, which is much better. And in the bank actor, we also need to treat this one because the bank is the one to search for the bank account actor. If it's not found, we return a none, and I'm going to return a failure. Again, I'm going to import that from Scala util with a new runtime exception saying the runtime exception saying the bank account cannot be found. So bank account cannot be found. Now I'm using try here, but you can use different data structures, and this is a little bit in contradiction with cats because we're using try here, but let's at least see that the error was solved, and then we can change this failure into maybe an either or something. So we have sum and we have success with the account and failure with an exception. And in the failure, I'm going to, first of all, I'm going to import these. So from Scala util to go at the top. So Akka util, you need to go import Scala.util, and then I'm going to try success and failure. All right, so we now have the types in place. So we have failure with an exception, failure response, and I'm going to return, instead of bank account, I'm going to inject x.getMessage or something. Let's see. Get message. All right. So we have that. Let's try to build it and let's try to recompile. I think my laptop is taking off. All right. So we're in the clear now. Let's try to go to the bank app and run the application again. All right. So now we have the server up and running. Let's try to put some money into Daniel's account. So we have amount is below the minimum threshold at the validation stage. I'm going to say amount minus 55. All right, so the reason saying cannot withdraw more than available, so the error was fixed. And instead of a 404, I'm going to return a 401 with a bad request. And I think we're in the clear, so I'm gonna, come on, IntelliJ, autocomplete this for me. All right. Cool, so at this point, our big application is complete, and we've used Akka Actors, Akka Persistence, Akka HTTP, we also have Cassandra for persistent store, and we also have Cats, JSON parsing, and a bunch of other goodies. All right, folks, so that was a giant journey. If you've gotten to this point, I massively appreciate it. I hope this video was useful and you got a lot of techniques out of this. If you like this video, go ahead and click the like button and check out Rock the JVM. It has tons of material on Scala, Akka, Apache Spark, Cats, and everything in the Scala ecosystem. We have courses on everything that you've seen here, including Akka Actors, Akka Persistence, Akka HTTP, Cats, and obviously the Scala language. And we have more than 200 hours at this point with the latest in the Scala ecosystem. So join us at Rock the JVM and follow Rock the JVM on Twitter and LinkedIn as I post fresh updates on upcoming material. Until the next one, folks, I'm Daniel, signing off.